Hey guys, welcome to Introduction to Complex Numbers. So the reason why we need complex numbers, or to see a complex number, we first have to see where it shows up. So if we go to solve this equation, x squared minus 81 equals 0, we add 81 to both sides, we get x squared equals 81, and then we square root both sides, and when we square root anything, you use the positive and negative. So in this case, we would just positive or negative 9, and we'd be fine. Could also factor that. But what about if we have x squared plus 81? Well, we subtract on both sides. We get x squared equals negative 81. And then what do we do here? Because we would have to do x equals the square root of negative 81. And like we've previously seen, when we have something that looks like this, we call it does not exist. Okay? Up until now. So these are what imaginary numbers are going to be used for if we get negatives under the square root. Okay, so plus or minus square root of negative 81 does not have a real answer. However, it has an imaginary or a complex answer. So to define a complex number, we have to create a new variable, and this variable is going to be lowercase I. Think lowercase I for imaginary. So the definition of I is equivalent to the square root of negative 1. And this is a representation. It's not a simplification. In other words, you don't take square root of negative 1 and just say, oh, well, that simplifies to I. No, we represent it. So basically, I is a variable for us, but it stands for a very specific number. So if I equals square root of negative 1, then I squared is square root of negative 1 squared. Okay, square undoes the square root, so that's why it equals negative 1. I cubed is simply I squared times I. I squared is negative 1 times I, so negative 1 times I is negative I. And I to the fourth is I squared times I squared, and we know I squared is negative 1, so negative 1 times negative 1, which is positive 1. So I cycles through, and then I to the fifth, we'll get all the way back to square root of negative 1, and we'll cycle through. Again, the main thing here we need to know is I squared is negative 1. So here's some examples. So how we deal with these. So we're going to suck out the I first and treat it as a variable. So square root of negative 36, I times square root of 36. Basically, if you have a negative under the square root, suck it out as an I, times square root of negative 81, suck the negative out, write it as an I, and now we get to write it as positive. Okay, I times square root of 36, square root of 36 is simply 6, so that's going to be 6I. Square root of 81 is 9, so that'll be 9 times I. So this will simply be 6 times 9 is 54. And then we get I times I. So 54 times I squared, we just saw I squared is negative 1, so this will equal negative 54. Okay, now what if we're adding these two things? Okay, well, negative square root of negative 36, we just saw as 6I. Square root of negative 81, we just saw as 9I. We can add the i's together just the same way we add x's together, y's together. Just treat just treat I like a variable. So 6i plus 9i will give us 15i. So two examples here. So what is a complex number? So we just saw two imaginary numbers, but what is a complex number? A complex number has two parts, a real part and an imaginary part. A complex number comes in the form a plus bi, where a is what we call the real part, and think all real numbers, 0, 1, 2, 3, 4, 5, 6, square root of 5, all the real numbers. And then bi is the imaginary part, where b is a real number attached to the I. Okay, so complex numbers come in the form a plus bi. So every complex number, has two parts, the real part and the imaginary part. And just FYI, all real numbers are complex numbers. Real numbers are subset of the complex. So if you have just regular old 3 is really equal to 3 plus 0i. And all imaginary numbers are also complex numbers. They just have 0 for the real part. Real numbers have 0 for the imaginary part. So again, treat the i's as a variable and you'll have no problems. Just consider it like an x. We can add the i's together, subtract the i's can go with the i's. So for example problems, so I have this complex number where a is 8, bi is 3i, and this complex number a is 6, and the complex part is negative 2i. So we can add the real parts with the real parts, 8 plus 6, and we can add the imaginary parts with the imaginary parts. So we just section them off. It's a plus in the middle. 8 plus 6 is 14. 3 minus 2 is 1, so I. So this would be the answer, 14 plus I. The real parts add with the real parts, the imaginary parts add with the imaginary parts. Again, just think of the I as a variable. Okay, now what about subtraction? Okay, well 8 minus 6 for the real part. And then for the imaginary part, 3 minus, so 3i minus negative 2i. So minus minus plus, 8 minus 6 is 2. 3i minus negative 2i, we're going to add those, so that'll be 5i. And that'll be the answer there. So just be careful with the sign in the middle. Okay, next, a little more complicated. Now, what if we need to multiply two complex numbers together? If you treat I like a variable, you'll have no problem. So think 8 times 6 is 48, and then 8 times negative 2i. 8 times negative 2 is negative 16. I, again, treat I just like a variable. It's the same thing we do if it was an x. Okay, 3i times 6, that'll be a positive 18i. 3i times negative 2i, that will be negative 3 times 2 is 6, and then I times I is I squared. Let's clean this up. 48 minus 16i plus 18i, that'll give us plus 2i, minus I squared is negative 1. Negative 1 times 6 is negative 6, and then we have the subtraction out in front. So that'll be plus, so this will end up being 48 plus 2i plus 6. 48 plus 6, that'll give us 54 plus 2i. The real part always goes first, the imaginary part always goes second. So if you have your imaginary part first, just rewrite it so it goes second. Okay. Lastly, we're going to look at a division problem. So division problem is something else is happening here, and it's a very big kind of math faux pas to have an imaginary number, a complex number, in your denominator. So I just rewrote this. This is this guy divided by this guy, so I'm just going to use, instead of divided by, I'm going to use a fraction bar. What we need to do here is we need to get the imaginary number out of the denominator. The way that we're going to do that is we're going to multiply it by its conjugate. Its conjugate is just the same thing, but with the opposite sign in the middle. So 6 minus 2i, the conjugate of that is 6 plus 2i. And we're going to multiply that on top and bottom. And we'll see now, I'm going to just throw parentheses around here just to make things easier to look at. We'll see now how the I is going to go away by using the conjugate. Okay, 8 plus 3i times 6 plus 2i, 8 times 6, 48, 8 times 2i, 16i, 16i, 3i times 6 plus 18i, 3i times 2i plus 6i squared. Okay, that's the top. We're going to clean that up. The bottom, notice this is a difference of squares. Okay, but we'll multiply it out, but you'll see the middle terms will end up canceling out. So we go 6 times 6, 36. 6 times 2i plus 12i. Negative 2i times 6, this will be minus 12i. Negative 2i times positive 2i, that'll be negative 4i squared. Okay. If we look at the denominator, plus 12i minus 12i, those guys blow out. So now back to our numerator, we have 48 plus 16i plus 18i. This will give us plus 34i. 6i squared. I squared is -1, so it's going to be minus 6. For the denominator, we'll get 36 minus 4 times -1, so this will end up being minus 4 down here. Clean it up one more time. 48 minus 6, this drops us down to 42, plus 34i, this is all over 36, minus -4, this will be all over 40. Okay, now we get to look at, is there anything we can do to reduce? Well, let's see, everybody is divisible by, what, 2 at most? So 42 will drop down to 21. So we're just dividing everybody by 2. 34 will drop to 17. And 40 will drop to 20. Okay, now these guys don't have anything in common. So this will be 21 plus 17i over 20. This is not in complex form because we need an a plus bi. So as a plus bi, it'll be 21 over 20. There's my real part. Plus 17i over 20. Now there's my imaginary part. Now I'm split into a plus bi form. And now we're done. Alright, that was it for complex numbers. If you guys have any questions, please don't hesitate to ask.